Right. Good morning to all. This is Subramaniam, Professor, Department of Computer Science Engineering, Keshav Memorial Engineering College. Today I am going to give lecture on signals and systems. Actually, this paper, Signals and Systems, seems to be a core subject of electronics, instrumentation and electrical branches. But really speaking, it is one of the part of CSE as well as other IT branches too. The link between CSE and electronics, just as a student, you have to explore. It's the hidden links of these two connections between CSE and ECE and electrical subjects. That's why this is the first point is just I am advising all students that don't treat signals and systems as a core subject of electronics or electrical only. It is a part of CSE or AML, what it may be. It is a part of these subjects too. That's why just we have to make this as how much subject concentration just we are going to have on this subject is very much needed. So now just we are going to start this subject, signals and systems. Our KMEC comes under the affiliation of Osmania University. As like all other subjects, this signal system subject 2 is divided into 5 units, unit 1, 2, 3, 4, 5 like that. Now just we are going to discuss from unit 1 onwards. Before entering into this unit 1, just we have to make some introduction to the signals and systems like that. Now let us start this. First one, just we are going to start with, now let us start the introduction to signals and systems. Actually, the title is concerned, signals and systems. These two are two separate domains. Without signals, no system works out. Without signals, no system works out. Similarly, without systems, signals are meaningless. How our breathing, oxygen, blood and flesh are required for human body. In this way, signals are more important to our systems. Just like the same concept just we can discuss in electrical engineering under the concept of control systems also. Human body is also a control system. So all these are interlinked, day-to-day related examples of this subject. Now just we are going to start with these signals and systems. First let us discuss. Actually first, what do you mean by a signal? After that we discuss what do you mean by systems? Like that. Signal. What a signal is? It is a mathematical representation of, physical representation of information flowing from one point to another point. That is called source to destination. Now just look at, for transformation of information, basically what do we need? We need a physical representation. That physical representation is called signal. A signal can be anyone. For example, just look at, just we learnt about audio signal and video signal and signals on telephone cables. Signals on telephone cables. Similarly, our heart graph ECG also contains signals, etc., etc. So whatever the signal type we take, all these come under the category of signals. Now basically just look at, one word is common to all these one. Audio, leave it, signal. Similarly, signal, signal. All these are signals. ECG graph is also a signal. It comes under the mathematical applications of Legendre's equation. Legendre's polynomials are the most important part of this ECG graph. So for all these kinds of signals, we need this definition of this signal part. Now basically just look at, a signal is a mathematical representation. A signal can be demonstrated by a mathematical representation. How can we represent it? For example, just look at x of t. We can write the same thing in terms of y of t also. This is called, just look at x of t. For after that I will discuss this one. Now just look at first one. A signal is basically a function of an independent variable. Just look at, a signal is a function of independent variable. Here at the beginning, just we take one independent variable, but as per the definition is concerned, a signal may be a function of one or more independent variables. Regarding the signal systems, which is a part of electronic theory, just we are making a definition like this. Now I am telling you the actual definition. A signal is a function of time varying. This time varying is an independent variable. Time varying. Varying means what? Variation. In intermediate paper 1B and 1B and 2B, how do we make it? For example, just look at, this is a dy by dx or d square by dx, sir. For that purpose, how do you write? This is the simple meaning of this dy by dx. In this way, x is independent variable, y is dependent variable. Now just look at, apply the same concept to signal definition. Signal is a mathematical physical demonstration of time varying phenomenon. Time varying phenomenon. That means what? As time varies from one point to another point, signal also transforming from one shape to another shape. That is called signal. So now usually just most of the part we are following this definition only. Again, just I am repeating, signal is a time varying physical demonstration for transformation of information from source to destination. That is called a signal. A signal can be a function of one or more independent variables. For example, just look at, we are writing x of t. X of t can be represented as a signal. That means what? Orally we say it is a signal, but how to represent the same signal mathematically? That is called x of t. This mathematical representation is called modeling, signal modeling. This word is very important. So x of t, this is called what? This is signal modeling. That means modeling of a signal. This is signal modeling. For example, look at here, what is t? T is an independent variable. What is x? X is name of the signal. X is name of the signal. What is this parenthesis? This parenthesis indicates a function. This parenthesis indicates a function. Just like in C programming, Java, C++, a function always represents like this, even in Python also. So now just look at, this is a whole representation of a signal. Now from this moment onwards, signal means students have to take this part into consideration, that is x of t. Now orally I say signal, but we have to make the representation as x of t. That is called a signal. Some others may write this as y of t, both are same. Even it is written either in the form of x of t or in the form of y of t. Both are same. Generally, we use the notation that is x of t is a signal. It is a signal. For example, just look at, we are making, you take any graph. In intermediate, just you take it as x, this is as y. This is called x-axis, this is called y-axis. This is up to intermediate. Generally for understanding purpose, for understanding of basics we do like this. But in electronics and electrical, we make it, this is called parallel axis. This is called vertical axis. Both are same, words are changing with little bit words changing. Here this is called x-axis, here we call it as parallel axis. This is called y-axis, we call it as vertical axis. Here we use as x, this is y. Actually y is called what? Y is also a function of X. So in electronics, we make it as T. T is a time. Here, this is X of T. So students, no need to confuse with this representation. Same graphical representation on XOY plane. Just we are taking the same representation for signal representation. In the previous case, we used this as X. The same thing is here denoted by small t. Here Y-axis. Here we call it as vertical axis. It is denoted by X of t. X of t is again it is Y. But we don't choose as Y. It is X of t. X is a function of t. That means what? As t is varying, accordingly y is varying. How it is varying? Now we have to discuss like that only. That's why it is called a time varying function. Signal means what? A time varying function. Here just look at in third semester, you already studied digital electronics. There is, you are making ripple counter, a ripple. How it transforms in this way, in the same way, this transformation here we are going to discuss here by the name of signals and systems. This is the basic introduction of signals. Now just look at, again I am taking one more time I am repeating it that from this moment onwards, signal means only X of t. Graphical representation means we are considering these representations, these. Now let us make it as, actually in the first unit, just like all other subjects, first unit is divided into two parts. That is called, one is called signals, second one is called systems. So now just we can make it as sub part 1, sub part 2 like that. So first unit entirely gives representation about introduction of signals, various kinds of signals, what kinds of operation just we can apply on signals like that. Once it is over, we will come to the second part, that is called systems. What do you mean by a system? What kind of systems are existing? How can we will link signals with systems like that? So unit 1 entirely provides introduction part. It entirely provides introduction part. Now unit 1, unit 2. Now let us start. Now just we are entering into unit 1. This is the full introduction part of signals and systems.